Today we are only going to cover division in regards to exponents. So this would be your blue and red card. So you want to go down to your blue card and flip the pink card up. All right, go ahead and copy our division rule down. Basically, when we are dividing, so 9 times out of 10 it'll be a fraction, you will actually end up subtracting your exponents from each other, and I'm going to teach you the correct way to handle that. You also have to be able to work with regular basic numbers. So for example, if you have, let's say, 4 over 10, you're still expected to reduce that to 2/5. Keep in mind, since this is dealing with exponents, I might sometimes write 4 squared over 10. You're still expected to know, okay, got to convert that to 16 and make that 10 and then reduce it to 8/5. So you still need these skills, but you're also going to be working with letters and exponents as well. Our model example has a little bit of everything, so go ahead and jot that one down. And you're going to want to write a little smaller than normal. The first thing that I like to do is anytime I have coefficients or I just have numbers down here, I'd like to go ahead and convert them. I don't want to work with 4 squared and 2 cubed. I'd rather work with 16 and 8. So I recommend you do that first. You can go ahead, if you want to divide 16 by 8, you can, or we can do that last. It doesn't matter. I just like to kind of do everything first and then write my final answer just to keep the steps very minimal. So then if you notice, we have a to the 7th and a to the 10th. So we call those like bases because they're both a's. What you're going to do is you're going to cross out the smaller. 7 is smaller than 10. And you're going to take that exponent from 10. So I just write a little 10 minus 7, just like that. So again, crossed out a to the 7th and subtracted 7 from 10. If you look at your p's, you have a 5 and a 3. So I'm going to cross out the 3 and subtract it from the 5. That way you never have to worry about negative exponents, and that's always a good thing. Once you do all your crossing out, you really just write your answer. So I know that 16 over 8 is really 2. On the top, I have what is now p to the 2nd power. And in the denominator, remember, we already took care of that 8. So if it helps, I would maybe do this. All you have is a to the what now will be 3rd power. And that's your answer. And so again, fractions need to be reduced, no negative exponents. Looks good. We're going to do another one just to make sure we actually get the hang of it. So the next example, I chose purposely to use 3 and 3 to the 4th. You have some y's and some m's. There's different ways to handle this. Some kids convert 3 to the 4th and make that 81. And that's fine. We could do that. I'm going to show you how to do it a different way, because if you had something like 3 to the 43rd power, you're not going to convert that. So you need to be able to work with the exponents, even if you have a number instead of a letter in the bottom. So first step is I want to put a 1 above this 3 because it really is 3 to the 1st. And I'm going to use the same rules I would use for my letters. Since 1 is smaller than 4, I'm going to cross that out, and I'm going to change this to 4 minus 1. And if it helps, if it's a little bit jam-packed, you can go ahead and write your answers as you go along. So this would just become, if you want, you can write a 1, you don't have to. And on the bottom will now be 3 to the third. Then I'm going to look at my y's. 2 is less than 4, so this one gets crossed out. And we're going to subtract 2 from the top. So you now have y squared on the top and no y's on the bottom. And if you look, m squared over itself, you don't really have to do anything with that because they end up just dividing off into each other. So if you want, you may just cross them out. Technically, you could write 1 and 1 here, but you don't need to write 1 in a multiplication problem. So I just kind of drop the m's. And then last but not least, 3 cubed is not a very big number. So I'm just going to write y squared on top. Remember, you don't need a 1 in front of a letter. That's not necessary. And 3 times 3 times 3 is 27. And that's it. Our last example has several 4x's in it. Again, that's done on purpose. And this is going to call upon your older rules. So you're supposed to take care of exponents outside the parentheses first. So we have to cube 4 and x. I'm just going to write 4 to the third, x to the third. On the bottom, I'm just going to copy my 4x. You're going to have to square 4 and x. So I'm just going to write times 4 squared x squared. I'm going to clean up the bottom a little bit. I see some combining I can do down here. Nothing really up top, so I'm going to leave that alone. It's always good to get your top and bottom as condensed as possible. That way it makes subtracting a lot easier. So it looks like you're going to have 4 to the third on the bottom, and you're also going to have x to the third. And if you're not sure where I got that, remember there are actual ones that you can't see right here. And if you add 2 plus 1, you get 3. Same thing for the x's. So this is actually a really good thing. 4 to the third simply reduces with 4 to the third. X to the third completely reduces with x to the third. No leftovers. So your final answer, you have to write something. It's going to be 1. Not 0. A lot of kids, when they see everything just canceling out or cross-reducing, they write 0. And that's not possible. If you have nothing to write, write a 1. It's a good thing to write this rule, so I'm going to have you write that. It is impossible to get 0 as an answer in division unless I gave you 0 in the numerator in the first place. So the only time you can have 0 as an answer is if I put 0 on the top. That's really it. So if I have a 0, x, y, m to the 5th power, okay, the whole top is just 0. So just get in the habit of not writing that. If you don't know what to write, go with 1. That's a safer bet.